So because a square is a special type of parallelogram, it has all of the properties of a parallelogram in addition to those of a rectangle and a rhombus. So it's literally all of them. So quiz yourself now and see if you can write all the properties, okay, that are on that pink sheet. If you don't know them all, use your pink sheet, but see if you can do as many as possible. You should for sure be able to get, what, 6, 7, 8, 9, 10, 11 of them. Okay, and then the other 3 were a little iffy, so if you need to go reference your pink sheet, that's fine, okay, because the other 3 are in relation to some of those other properties. Okay, so see how many you can do based off memory. Challenge yourself, because you need to know these things. So go all down the parallelograms, all down the rectangles, and rhombi, and then squares. And then once you get to those last 3 that are missing, if you'll go to the rectangle column on your pink sheet, you'll find the last 3 that we had checked. I think the 3 you're missing will be in terms of your consecutive angles being supplementary, congruent. Give you 2 more minutes. Once you are finished, go ahead and check off everything on your squares column on your pink sheet. if you are missing any, just kind of check them off as I say them. Okay, opposite sides are parallel. Opposite sides are congruent. All sides are congruent. Consecutive sides are congruent. That's probably one you're missing if you are filling in your last few. Opposite angles are congruent. Opposite angles are supplementary. This is Coach Cologne. Hi. Yes. Okay. You're welcome. I think you missed my class more than any other one. Yeah. Okay, just make sure you watch the video because you have a quiz next time. Okay? 7 is consecutive angles are supplementary. 8 consecutive angles are congruent. 9, all angles are right angles. And if you want to take your skills check tomorrow, B block, that's fine. Okay. 10, diagonals are congruent. 11, diagonals are perpendicular. 12, diagonals bisect each other. 13, diagonals bisect bisect opposite angles. And 14, diagonals form 2 congruent triangles. Question. Okay, so now we are going to put everything into practice. Example 1. Math is a square. Okay, if MA equals 8, then HT equals 8. If the measure, or what is the measure of HST? 90. Why is it 90? Because diagonals bisect each other. Okay, what about MAT? 90. Because all angles are right angles. And if HS equals 2, then HA equals 4. Because SA would be 2 as well. And MT equals 4. Because your diagonals are congruent and they bisect each other. Squares are your friends. Angles maybe not, but we'll see. Okay, example 2, using square ABCD and the given information to find each. Okay, so for A, AED is 5x plus 5. What do you know about the measure of AED? It equals 90. So 5x plus 5 equals 90. Subtract 5 from both sides. You have 5x equals 85. Divide. So what does x equal? 17. Okay, what about the measure of BAC? What do you know about that guy?
45.
45 degrees. How do you know that it's 45 degrees? It's 90 degrees. This BAD is 90 degrees. And then it's bisected because diagonals bisect opposite angles. So you have 45 and 45. So you have 5x equals 45. So x equals 9. Okay, and that's all we got really for squares. Questions about the good old square? When in doubt, it's probably a square. Okay, it has every property of parallelogram, rectangle, and rhombus. Okay, moving on then to the next part, which is angles. Okay, so angles of polygons. Okay, a polygon is a closed figure formed by segments that intersect with each other at their endpoints. So basically, a polygon is a closed figure, okay? Alright, polygons are named according to their number of sides. Let's see how far we can get down this list. A three-sided polygon is called what?
Triangle.
Triangle. Four-sided?
Square.
Nope. Quadrilateral. Good job. Five-sided? Pentagon. Whoa. Six-sided? Hexagon. Seven-sided?
Septagon.
Sept?
Isn't it heptagon?
Heptagon.
What? You'll learn it in chemistry. Yeah.
Eight-sided? Octagon. Nine-sided? Nonagon.
Chemistry is really cool. Yeah, it really is.
Ten-sided?
Decagon.
Decagon.
11.
11.
Decagon plus 1. Is that it? No.
So I'm probably going to butcher this when I pronounce it. It's either undecagon or undecagon. It's like uno. Undecagon. I've never heard of that. So. Okay, for 12, what is it? Dodecagon. Or dodecagon, however you want to say it. Tomato, tomato. Okay, and an n-sided polygon is called what? An n-gon. So like after 12, guys, listen. After 12, say you have 13 sides, just a 13 gon, or a 14 gon, or 15 gon. That's it. What? N-gon? Like, for n number of sides. So say that there's 36 sides, or 58 sides. Like, so anything after 12, just n number of sides. That was fun. Okay, interior angles. Guys, we gotta get through this. Refocus. Maybe. Okay, refocus. Okay, this could be challenging because you have to memorize these formulas. Okay, so pay attention. Interior angle theorem is the sum of the measures of the interior angles of a convex polygon with n sides. Okay, so what does it mean to be interior, do you think?
On the inside.
Inside, so all of your inside angles. Okay, so the sum of interior angles this is what you have to memorize, is 180 times the number of sides minus 2. And that's how many that's the measure of the sum of your angles within your polygon. Okay, so if I had a triangle, I would say 3 minus 2, which is 1. 1 times 180 is 180. And we know that the sum of the interior angles of a triangle is 180. Okay, same thing if I were to do a square. We know the sum of a square's angles is what? 360. So 4 minus 2 is 2, times 180 is 360. Okay, so this is why, okay, this is the formula you use to figure out the sums of those interior angles. Okay, so that is what you have to memorize, so I'll mark it for you. Memorize. Okay, that is not on any sort of formula sheet. Okay. I always mispronounce this word. Similarly, it's just a mouthful. Try to say that like 5 times fast. No, it sounds weird. Okay, there is a formula to find the sum of the measures of the exterior angles of a polygon. Okay. However, there's not really a formula because the sum of the exterior angles is always equal to 360 degrees. So all of your exterior angles will always equal 360 degrees.
How does that work for triangle?
What do you mean?
Like interior is 180, right?
Mm-hmm.
If you calculate the exterior angles, how does that add up to a 360 for triangle?
let's say if we have 60, 60, 60, this exterior angle has to be 120.
Oh, okay.
This exterior angle is 120, and this exterior angle is 120, so that's 360. Okay, good question. So number 3 says find the sum of the interior angles of a 20-gon. So how many sides does that have? 20. Okay. How do we find the sum of our interior angles?
180 times n minus 2.
Very good. 180 times n minus 2. So you have 180 times 20 minus 2. 180 times 18. You don't have to be in degree mode or anything. 3,240 degrees. So inside of a 20-gon, there's 3,240 degrees amongst your 20 angles. Okay? A regular polygon is a polygon that is both equilateral and equiangular. Most of the time when we think of equilateral, what do we think of?
Square.
Triangles. Most of the time when I say it's the equilateral, most people would say triangle, even though I got 2 answers that weren't triangle. But just know that equilateral means that all the sides are the same. Okay, there's not just equilateral triangles, there's equilateral hexagons, equilateral pentagons, okay? Equilateral simply just means all sides are congruent. Okay, the corollary, the measure of each interior angle of a regular polygon with n sides. Okay, again, this is something you have to memorize. Each interior angle equals 180 times n minus 2. What do you think I have to do? Divide by n. Because I want to know what, now I know the total, but now I'm going to divide it by n number of sides to figure out what's the measure of each angle. Okay? So, if I go back to example 3, what would be the measure of each interior angle?
162.
Is that, I don't even know. 162. Okay, so you take your total divided by 20 and you got 162.
So you would just divide that by 3,245.
Yep. Because this was already the 180 n minus 2 piece, and then you're just dividing it by total number of sides. Okay, and again, you have to memorize this. Okay, this whole unit is pretty much memorizing. Yay. Okay, similarly, you can find the measure of one exterior angle of a polygon by using what? What do you think? I heard somebody whisper it. 360 divided by n. Okay, because you know the total of our exterior angle is always 360 degrees. So if you divide it by the total number of sides, you get the measure of just that one exterior angle. So, to go back to your triangle, Monica, 360 divided by 3, and each of your exterior angles would be 120. And that's only because it's a regular polygon. Like, obviously, that's not going to work with like a 30, 60, 90. Okay, because each of your exterior angles are going to be different. This has only worked with regular polygons. And angles are equal. Okay, example 4. Find the measure of each of the interior angles of a regular dodecagon. Dodecagon, how many sides? 12. Okay, so we're looking for the measure of each of the interior angles. So what do I need to do? 180 n minus 2 over n. Okay, so 180 12 minus 2 over 12. Hold on. 180 times 10 over 12. Very good. 150 degrees. Okay, example 5 says that if the measure of an interior angle of a regular polygon is 150 degrees, find the number of sides in the polygon. Well, that doesn't really help that we just did it, but we're going to pretend like we didn't do number 4, okay, and we have to work backwards. Okay, so we know that, like I said, the measure of an interior angle is 150. Okay, so you know that 150 equals 180 times n minus 2 over n. Correct? Okay, what is the first step I'm going to have to do? Multiply both sides by n. That cancels out that n. So now I have 150n equals 180n minus 2. Okay, very good. Somebody's whispering it back there. Distribute. So you have 150n equals 180n minus 360. Subtract 180. And what do you get on that side? Negative 30n equals negative 360. Divide. And what do you know? What do you get? 12. Okay, it might say the number of sides. It could also tell you to name the polygon. Okay, so you will never be asked to name something. Well, I mean, if you were to ask to name a 26-sided polygon, it would just be 26 gone. But just make sure you're familiar with the ones that are on the front. Those are probably actually easier than the ones that you actually do have to name. Alright, example 6. Given a regular nonagon, find the following. How many sides does a nonagon have? 9. Okay, how do we find the sum of the interior angles? 180 times n minus 2. So 180 times 9 minus 2. But it wants the sum of all of them. Not the each one, just the sum. Okay, so 180 times 7, and what do you get? 1,200. Awesome. Okay, so I'm glad that both of you guys brought that up. When it says the sum of the angles, it wants all of them. If it were to ask, like up here, find the measure of each interior angle, that's when you're looking to divide by n. And here we are in letter B. Measure of each interior angle. Now we take that 1,260 and do what?
Divide by 9.
Divide by 9. So what is the measure?
140.
140. Okay, so look for those words, sum versus each. Okay, what about the sum of the exterior angles? It's always 360 degrees. Okay, and then how do we find the measure of each exterior? 360 divided by our number of sides. 40. Alright, example 7. Says find the missing angle. Okay, how many sides do we have here? 6. Okay, what? 6 sides. Okay, how do we know the sum of the interior angles? 180 times n minus 2. So 180 times 6 minus 2. And what do you get? 720. Okay, so you know that the sum of all of them needs to be 720. So how do you figure out x?
multiply 720 minus all the stuff.
Very good. So 720 minus 90 plus 130 plus 130 plus 130 plus 120. Yes.
I thought we had to only use it on regular, figures, regular polygons.
So regular polygons is for the exterior angles or only the exterior angles. So the interior angles is any convex polygon. Oops. Okay, so example 7 is what?
120,
X equals 120 degrees. Questions on 7? Okay, 8 we're going to do 2 ways. I'm going to show you the long way or the most logical way, and then I'll show you a shortcut that always works. Okay? Example 8 though says the sum of the measures of the interior angles of a polygon is 5 times the sum of its exterior angles. How many sides does the polygon have, and what is the name of the polygon? Okay, so you will see this problem a lot. Okay, so the first way to show to solve it is by setting up an equation. Okay, the sum of the measures of the interior angles. What equation is that? 180 times n minus 2. Okay, it says the sum of the measure of the interior angles is equals 5 times the sum of its exterior angles. How would we write that? 5 times 360, because it's 5 times greater than the exterior angles. Okay, and then from here you just solve for n. Okay, so you have 180n minus 360 equals, I have no idea, what's 5 times 360? 1,800. Add 360 to both sides, and you get 180n equals 2,160. Divide by 180, and how many sides do you get? 4. Which is called a dodecagon. Okay, now I'm going to show you the shortcut. Okay, the shortcut always works, but I don't have a very good explanation as to why it works, which is why I wanted to show you this way that always works as well. Okay, say you have a pentagon, and that's what, or not even a pentagon, I'm not going to say that. But like this is the angle inside your shape. Who knows? I have no idea. Okay, basically if you put the interior angles together in this side, okay, then you put your exterior angle on the other side. Okay, so you have your interior angles as x, and then how many times greater is your exterior angles? 5x, okay? And so then, what do you know about any interior angle with the exterior angle? What does its sum have to be? 180. So x plus 5x equals 180. 6x equals 180. Not yet. X equals what? 30. Okay, so you know that one of your exterior angles is 30. Okay, so then if you do 360 divided by 30, now you get what? 12. Okay, so this method would always work as well, but I don't have as good of an explanation, so the first way might be easier. So if that just totally like went phew, just ignore it and go back to step 1. Okay, but that one works as well.
What was the final step?
You take your exterior angles divided by the measure of your one exterior angle to figure out the number of sides.
Okay.
Okay, Example 9. Find the value of x.
Haven't we done these before?
Yeah, this is review. How do you find the value of x?
2x plus 1 plus 3x plus 8 equals x plus 21.
Very good. What do you call these two angles? Consecutive, but what did we call them before when we did this type of problem? Starts with an R. Remote.
Oh.
Interior angle. So you have your exterior angle, and then you have two remote interior angles. Okay, and then you're just solving for x. So you combine your like terms. 5x plus 9 equals x plus 21. 5x minus x is 4x. 21 minus 9 is 12. So x equals 3. Any questions? Okay, I'll try to work on another way to figure out example 8, but like I said, the first method will always work and the second method always works as well. Alright, I am coming around with your homework.